In this video, we're going to see how mass spectrometer can be used to determine the mass of an atom or a molecule. And we're going to use mass spectra to calculate the relative atomic mass of an element. In our course, we're going to see how the mass spectrometer can be used to identify the number of isotopes and the relative abundance of the isotopes. Now there are a few main steps. Sometimes you'll see they'll be combined. So the first section is vaporization. We have to turn our sample into a gas. So it must be a gas. And this occurs here. So this is one. The next step is ionization. And this is where we use a beam of electrons or a stream of electrons to knock one or more electrons to form a positive ion. So for example, if you've got a magnesium, which is a gas now, when you pass it through a stream of electrons, one of the electrons could end up being knocked off and you end up with a magnesium ion. So it's very important here that when you do an ionization, that they are gases. Ionization means to make ions. This occurs here. The next step is acceleration. So at this point in time, we accelerate the ions through an electric field to ensure they all have the same kinetic energy. This occurs here. Now, sometimes you'll see they'll have them combined. At this point here, deflection. The ions are deflected by a magnetic field. So the lighter the ion, you get more deflection. And the more positive the ion, you get more deflection. The last step is detection, and that occurs here. And the beam of ions is detected electrically. Now let's look at how to use a mass spectrum. So from this mass spectra, you can see that there are in fact two isotopes of lithium because we have two peaks. Now from here, the first thing you need to do is determine the sample size. And from this mass spectra, you can see the sample size is equal to 8 plus 100, which is 108. Now what you can do is calculate a weighted average to determine the relative atomic mass. So atomic mass has the symbol A. Relative means the little r. It's for lithium, so I'm telling my marker what I'm doing. You can see here that 8 out of 108 have a mass of 6, plus 100 out of 108 have a mass of 7. So using my calculator, I can find that this will add up to 6.93 as a relative atomic mass. It doesn't have a unit because it's in comparison to carbon-12. Now let's try another example. So we're going to calculate the relative atomic mass of magnesium. You can see here that there are 3 isotopes of magnesium. We have magnesium 24, magnesium 25, and magnesium 26. The sample size is 100 because we know this because it's a percentage. So now we can calculate the relative atomic mass of magnesium. So we have 78.7 divided by 100 times 24, add 10.13 over 100 times 25, add 11.17 divided by 100 times 26. Using my calculator, I can now calculate this out, and it comes out to 24.32. Remember, there are no units. Now I'd like you to try some for yourself. If you go to the OneNote, atomic structure, and then atomic structure again, isotopes, there's 3 examples for you to try, and I've made a video of the worked examples for you to check your understanding. Good luck.